Hello again. This little clip should give further examples with regards to molarity, molality, mole fraction, and the like. Solution concentration examples specifically using sulfuric acid, the most common industrially produced acid or chemical compound in the world. Here's a bottle of it. I think for a gallon of sulfuric acid, it's like $10. It's like super inexpensive. It's produced by Kennecott as a byproduct in some of their cleaning operations. Here's H2SO4 is the formula, and the structure, the bonding. This hydrogen dissociates, comes off when put into water, and creates an acidic solution. But it's amazing how concentrated sulfuric acid can be. It can reach 18.4 moles per liter. That's 18.4 molar. It's a huge coincidence that the density of concentrated sulfuric acid also has the same digits in grams per milliliter. So the density of water is 1, the density of sulfuric acid is almost 2. So it's a lot more dense, a lot more thick, a lot more syrupy and viscous. In 1 liter of sulfuric acid, 18.4 moles. In a half a liter, half as many moles. In a tenth of a liter, a tenth as many moles. So I guess it would be, 1.84 moles or 1840 millimoles in that 100 milliliter sample. Something to think about proportionally, or what the proportionality means, and how that 18.4 doesn't change. For concentrated, that's a description of how much is in a particular liter. 1 milliliter, the reason why they told me that the density was 1.84 will become obvious in a minute, but I might just think about what that means. That means 1 milliliter of sulfuric acid concentrated has a mass of 1.84 grams, or 1 full liter, like this whole liter, would weigh 1,840 grams. And I was just making a note again, it's a weird coincidence that the density is the same, has the same numerical digits as the molarity, which is no connection. But let's get into a question with regards to concentrated sulfuric acid. Molarity 18.4 molar, density 1.84 grams per milliliter. What's the mass percent and mole fraction? Well, mass percent compares the mass of H2SO4 to the total mass altogether, and the mole fraction compares the moles of H2SO4 to the total moles in the mixture, again, altogether. But again, 18.4 molar means 18.4 moles per liter. I might change moles into grams. That will give me a sense of the mass of H2SO4 in a liter of solution. And here I've just added up H2SO4 and multiplied that sum by 18.4. I got about 1,800 grams for a liter of solution. Ooh, I apologize. 1,805 grams of H2SO4 in a liter of solution, which I might remind you had a mass a little bit more altogether. So the mass of the solution altogether for a liter was 1,840. So the difference between 1,840 and this 1,805 number must be the grams of water that's in the mixture, which is only 35 grams of water, which is an amazingly small amount of water considering how much sulfuric acid we have. Again, converting moles of H2SO4 per liter gives me the same result I had above. So the mass percent would be 1,805 grams of H2SO4 containing 1,840 grams of solution altogether to give me about 98% sulfuric acid. So in a mixture of concentrated sulfuric acid and water, I have only a little bit of water left. It's at 1.9% water and 98.1% H2SO4. It's an amazingly concentrated and pretty amazingly dangerous acid because it's so concentrated, and it's classified as a strong acid as well, which we'll talk about again someday. Um, let's see. If I would like to find the mole fraction of H2SO4 in concentrated acid, concentrated sample of acid, I might think about moles of what compared to moles of what. In that 35 grams of water, which isn't very much water, 35 grams of water, 1805 grams of H2SO4, this reflects the density of the solution. This is the molarity of the solution. I only have 35 grams of water, which converts to 1.94 moles of water. The total moles in the mixture, I think from above we had 18.4 moles of H2SO4 in the liter, and that comes out to only 1.94 moles of water, total number of moles. So mole fraction, chi, of H2SO4, 18.4 moles of H2SO4, 20.34 moles of molecules altogether, comes out to 0.905. Or I could say 90.5 mole percent. The sum of this mole fraction and this mole fraction should come out to 1. So I think if I did my math right, the mole fraction of water is only 0.095. It says, find the volume of this concentrated acid needed to dilute to 1 liter to make a 5.2 molar acid. I think we saw this on the previous video, but a review. Molarity concentrated times volume of concentrated equals molarity of diluted times the volume of the diluted. This left-hand side is the moles of the concentrated, and I'm just going to add some water to it. I'm not going to take away or add any moles of acid, so the moles after equal the moles before. And I want to make 5.2 molar, I want to make 1 liter of 5.2 molar acid, and I want to use a certain volume, I don't know what, of that concentrated acid. So this is a very famous equation. I suppose the sooner we become comfortable with when to use it and how to use it, the easier our lives will be in terms of stoichiometry, dilution equations, and such. So 5.2 times 1 divided by 18.4 gives me the, oops, that's mislaid. No, it's not. That's correct. That gives me the volume of the concentrated acid I should use. So if I took 283 milliliters of concentrated acid and watered it down to 1,000 milliliters or a liter, that would create a lessened molarity, a watered down, a little bit safer version of that acid at 5.2 molar. Let's see, what's the molality? Molality of the 5.2 molar. It's a little bit trickier. Molality is moles of solute per kilogram of solvent. So let me think about this. Oh, I have the diluted 5.2 molar. That means 5.2 moles in a liter. But how many kilograms of water? What I really need to know, the massive solvent that did the dissolving, which is kind of an odd idea. You might argue that I have more solute than solvent, which confuses things sometimes. Assuming 1 liter volume, how much of this 5.2 molar acid solution is sulfuric acid and how much is water? Well, again, I could convert moles to grams in a liter. So there's my diluted molarity, my grams to molar mass of the sulfuric acid. They told me the density was 1.38 grams per milliliter, and that tells me the total grams, the total mass for 1 liter, 1380 grams. So in this 1380 grams total of the 5.2 molar, I have 510-ish grams of acid. That means the difference between this one and this one must be water. The total is the acid plus the water. So how about 1380 total minus 510.1 over to 3 sig figs. This only goes to the tens place, so I'm going to have to round my answer to the tens place in any case. 870 grams of water. That was the mass of water that did the dissolving. So now I think I'm ready to find my molality. That is the 5.2 moles of acid in 0.8 0.870 kilograms of water. I got that 870 grams is 0.870 kilograms, and it comes out to 5.98 molal. And we still haven't given many examples of why we care about molality, but as we'll see in just a couple of videos or lectures, the molality speaks a lot to the properties we call colligative properties. Hey, here's a related problem if you feel ambitious, and I hope you will. Try this before class, after class. I don't know if I'll address it in class, but if you have a question, it's a similar acid, hydrochloric acid, 36% hydrochloric acid. I don't recollect if this is indeed as concentrated as hydrochloric acid can become, but 36% mass percent would mean That's 64% water and 36% acid. That still seems fairly concentrated and slightly dangerous. It says assume a 100 gram sample and calculate the mass of HCl and the mass of water in the mixture. And then from that you should be able to find the mole fraction and the molality of the molarity. Yeah, you should be able to. Anyways, have fun, and I'll see you next time. Thanks. Oh yes, I am Sardi, and in addition to that, to solve this problem, you need to know that, right, to do this, where we find the molarity and percent, it's 36%. What's the mole fraction? We could do the molarity and the molality, but we also really need the density. So how many grams per milliliter? And then if I assume a certain portion and go from there, everything else should calculate out. Thank you.